Peace be upon you, dear students. This video will be about acidic and basic solutions, and it will discuss mainly indicators. At the end of this video, you will be able to classify solutions into acidic, basic, and neutral using a color indicator. Before starting, be sure that the chemistry worksheet is in front of you, of course with a pen or a pencil. Let's start. Chemical substances are part of our daily lives, such as vinegar, baking soda, lemon, Java water, soda, hydrochloric acid, sodium hydroxide, acids used in car batteries, and liquid soap. These substances can be classified into two groups, acids and bases. Are you wondering how do we determine whether the substance is acidic or basic? It's not by tasting, nor by smelling, and neither by touching it, but rather it is by using color indicators. What is a color indicator? A color indicator is a substance that indicates if a solution is acidic or basic by changing its color. For example, red cabbage water, which has normally a purple color, becomes red when mixed with acids and gives any of these colors when added to bases. Litmus paper and phenolphthalein are also examples of color indicators. Now, open on worksheet 22 and we are going to solve it together. Starting with the experimental part, the materials used are vinegar, lemon, soap, Java water, hydrochloric acid, sodium hydroxide, test tubes, phenolphthalein indicator, blue litmus paper and red litmus paper, and finally an eyedropper. Keep in mind that while watching the next slides, you are going to record your observations by filling the table in worksheet 22. You are going to fill it by using colors, for example, yellow, red, colorless, and so on. Moving to the procedure. Lemon, vinegar, soap, Java water, hydrochloric acid, sodium hydroxide, each is placed in a separate test tube, and phenolphthalein, which is initially colorless, is added to each substance. Observe the color obtained and record your observations. After that, the same procedure is repeated but using blue litmus paper this time. Observe and record your observations in the second row in the table. Finally, the procedure is repeated again but using red litmus paper this time. Keep in mind to fill in your observations in the third row in the table. Now, take 1 minute and correct your observations. Let's try to analyze the results obtained together by solving number 1 and 2 in worksheet 22. But before, we can notice that each indicator gave two different colors with these substances. Let's move now to numbers 1 and 2 in worksheet 22. Pause the video and give it a try to solve them alone. So let's correct the answers of numbers 1 and 2. 1. Classify the substances in two groups according to the obtained color when using different indicators. We can put lemon, vinegar, and hydrochloric acid together in the same group because they gave same colors with the three different indicators. Similarly, we can put soap, Java water, and sodium hydroxide together in the same group because they also gave same colors when used with the three different indicators. 2. Give a title for each group with the help of the teacher. So, what do you think? What can you give as a title for Group A and Group B? Group A can be named as acids and Group B can be called bases. Let's continue experimenting. We are going to repeat the previous procedure but with water and salty water this time. During this time, we are going to solve number 3 in worksheet 22. In this part, we placed each of water and salty water in a test tube, and we are going to see the effect of the three indicators used on them. Don't forget to record your observations. The results obtained are as follows. Phenolphthalein remained colorless with water, blue litmus solution remained blue with water, and red litmus solution remained red with water. Similarly, phenolphthalein remained colorless with salty water, blue litmus solution remained blue with salty water, and red litmus solution remained red with salty water. As we can see, that the indicators didn't have any effect on water and salty water. Pause the video and continue solving the last part of worksheet 22 alone. Let's correct the answers together. A. Can we say that water and salty water are acidic or basic solution? Justify. Water and salty water are neither acidic nor basic because they didn't change the color of the indicator. Note that a solution that is neither acidic nor basic is neutral. B. Describe water by one word. Yes, it's neutral. Let's sum up the ideas that you must be familiar with. A chemical substance can be acidic, basic, or neutral. To know the nature of a solution, we can use an indicator, but keep in mind that indicators don't change color in neutral substances. We'll end up this video by evaluating yourself. Methyl red is a chemical substance that has a yellow color and it becomes red in acidic solutions, but in basic solutions it remains yellow. As we see that methyl red changes its color according to the nature of the solution. Describe methyl red by one word and justify. Methyl red is an indicator since it changes its color and different nature of solutions. A solution in the lab is of an unknown nature, which means we don't know if it is acidic, basic, or neutral. Explain a method that helps in determining its nature. We can determine its nature by using method red indicator. If the indicator turns red, then it's acidic. However, if it remains yellow, then the solution is basic or neutral. Thank you for watching.